All right, so 5-6. This is just a one-page 5-6 equations of quadratic functions from their graphs. We've already done this a little bit in a couple of different, there's a couple ways to see this problem. Okay, do you remember this sheet, the practice worksheet that we did a couple days ago? Okay, we had graphs. So we basically were doing exactly this. We were coming up with equations of quadratic functions from their graphs. So sometimes you're given a graph or information about the graph, and from that you have to come up with the equation. Okay. This first problem, we're coming up with an equation based on just any 3 points on the graph. Okay, so you're given any 3 points anywhere in the coordinate plane. If you think about that, any 3 points you could fit a parabola to. So let's say you had a point over here and a point over here and a point over here. Okay, well, that parabola, knowing it had to open up or down, okay, we're not doing any sideways parabolas opening to the right or left, but we know that this parabola would have to open up to get through these 3 points. There's no way it could open down and hit all 3. It somehow would have to fit in here and hit all 3. Now, we would not necessarily know that this was the vertex. We cannot assume that, but we would know at least that it opens up. Okay, let's say you were given 3 points here. Okay, any 3 points that you could possibly draw on a coordinate plane, you could fit a parabola opening up or down to. Okay, so based on that assumption, if we were given these 3 points and we had to come up with an equation, and here we want to come up with the equation in standard form. Okay, we cannot assume one of these 3 points is the vertex. It'd be nice if we could, but without them telling us that, we can't assume that. Okay, so by a linear system. So basically, you're going to come up with an equation for each of these 3 points in this form. So I'm going to write this up here. Ax squared plus bx plus c equal to y. Okay, so I'm going to cut 3 equations, an equation from each of these points. So the first point is -2 comma 15. Now plug the -2 in. Remember, this is my x, this is my y. Plug -2 for x, and then plug in the 15 for y. So a times -2 squared plus b times -2 plus c is equal to the y value of 15. There's my first equation. Now I'm going to come up with another equation from this ordered pair. 5 comma 15. I'm sorry, 5 comma 36. 5 comma 36, which means my x is 5. So I've got a times x squared, a times 5 squared, plus b times x, b times 5, plus c is equal to the y value of 36. And the last ordered pair, 3 comma 10, I can come up with a third equation. So that's a times x squared plus b times x, which is 3, plus c is equal to our y value of 10. Okay, now simplifying all 3 of these, I get 4a minus 2b plus c is equal to 15. 25a plus 5b plus c is equal to 36. A times 3 squared, so 9a plus 3b plus c is equal to 10. Okay, now we're not going to solve by matrices, so I can use all this space. Okay, so we can solve for a, b, and c because we've got 3 equations with 3 unknowns. Okay, once we know a, b, and c, once we solve for a, b, and c, we can plug them back in for a, for b, and for c, and that's our equation in standard form. Okay, so I think it would be easiest to pick the first 2 equations, and I'm going to eliminate c. C is easiest to eliminate. And then I'm going to pick 2 other equations. So I'm going to pick the second and the third equations. And again, I'm going to eliminate c. So what I will be left with, when I take these 2 equations here and I eliminate c, I'm going to be left with an equation that just has a's and b's. When I take these 2 equations and I eliminate C, I'm going to have another equation that only has A's and B's. And once I have the two equations with the two unknowns, then I can solve. Okay, so let's do this. I'm going to take, let's do this. Let's take the second equation and subtract the first equation. So 25a plus 5b plus c equals 36. And I'm going to subtract the equation. 4a minus 2b plus c is equal to 15. Okay. So the homework tonight on the assignment sheet, for a couple of the problems, it asks you to solve these by hand. And for a couple of them, it asks you to solve using the solve feature on your Inspire. Okay. So we're going to do one. We're going to do one with the by hand, and then I'll show you how to solve it on your, I'll remind you how to solve it on your calculator. Okay. So 25a minus 4a gives you 21a. 5b minus 2b is 3b. I'm sorry, minus a negative 2b gives you plus 7b. C minus c, that goes away. 36 minus 15 gives you 21. Okay. Now let's look at these two equations. And I'm simply going to take the second equation and subtract the third equation. So I'll take 25a plus 5b plus c equals 36. And I'm subtracting the equation 9a plus 3b plus c equals 10. 25a minus 9a gives me 16a. 5b minus 3b gives me plus 2b. C minus c, that goes away. 36 minus 10 gives me 26. So now I've got these equations, and I need to solve that system. Okay, so let's bring these over here. 21a plus 7b equals 21. And I've got 16a plus 2b equals 26. Okay. So solving, I'm going to eliminate the b's. I think that'd be easier. I'll multiply the first one by 2. Multiply the second one by negative 7. Okay. Let's bring this down. And I will get 42a plus 14b equals 42. Negative 7 times 16. 7 times 16, 112. So negative 112a minus 14b equals 7 times 26, 182. Negative 182. Okay, so 42 minus 112 gives you negative, what is that, negative 70 equals, and then 42 minus 182 gives you negative 140. Divide by negative 70, and a is going to equal 2. Okay, let's bring that a, plug it back into, we can plug it into either of these two equations, this one or this one. I'll just plug it in here. 16 times 2 plus 2b equals 26. 32 plus 2b equals 26. 2b equals, subtract 32, I get negative 6, so b equals negative 3. Okay, and then I can plug a and b back into any of your original equations. Let's just plug it into the first one. 4a minus 2b plus c equals 15. So 4a, a is 2, minus 2b plus c equals 15. So that's 8 plus 6 plus c equals 15. 14 plus c equals 15. So c equals 1. Okay. So ABC is equal to 2, negative 3, 1. Okay, that would be your solution, but that's not the solution to the question we were asked. We were asked to come up with an equation. So we're going to plug in A, B, and C into this equation. So our equation is y equals a 2x squared minus 3x plus 1. Okay, then let's solve this on the Inspire. Okay, so basically what we're going to do here, we're going to take these three equations right here. We're going to plug them into the solve system. Okay, so let's go back to this. Let's just start a new page. So doc, file, new document. We don't need to save that. Just add a calculator page. And here you go to menu, algebra, solve system of equations, solve systems of linear equations. We can make it more specific. There are three. And then it'll give us x, y, and z. But look at our equations. Our equations don't have x, y, and z in them. They have a, b, and c in them. Let's do a, b, c. Okay. Then we can type in our equations. 4a minus 2b plus c, equals 15. 25a plus 5b plus c equals 36. And 9a plus 3b plus c equals 10. 4a minus 2b plus c equals 15. I always like double check. 25a plus 5b. Ooh, that should, yeah, plus 5b plus c equals 36. 9a plus 3b plus c equals 10. Okay, hit enter, and we get the same answer. A is 2, b is -3, c is 1. Okay, so that's how you would solve using the Inspire. Now, one last thing that's kind of fun to do is to graph this. So let's graph the solution. Let's graph the equation we got. We're going to just do add a page. So to add a page, you do, it's plus page up here. So control, doc. The page we're going to have is add as a graphing page. And we're going to just type in our equation, 2x squared minus 3x plus 1. And let's just double check that it actually passes through these 3 points. Okay, so let's do a menu, 5, 1 for graph trace. Okay, the 3 points, -2, 15, so type in -2, hit enter, -2, 15, you can see that right down here. Next was 5, 36, so just type in 5, hit enter, 5, 36, that works. And then the last one, 3, 10. 3, hit enter. 3, 10. So we know we did it right. All right. Oops. I'm going to go back to this page. Okay. And let's do the last one. The graph of a quadratic function has a vertex at the point 3, -6, and another point on the graph 7, 5.2. Find the particular equation in vertex form. So this is very similar to what we did on this page. Okay, you were given a vertex and you were given another point. So vertex form is y equals a times x minus h quantity squared plus k. And it says our vertex is this, so that's the h, that's the k. H is 3, k is -6. So y equals a times x minus 3 squared plus k, so -6. Okay, we're almost done. We almost have everything. We just need to solve for a. So fortunately, they gave us another point, 7, 5.2. Plug in a 5.2 for y equals a Plug in the 7 for x. 7 minus 3 squared minus 6, and then you just solve. Okay? So 5.2 equals 7 minus 4 is 7 minus 3 is 4. 4 squared is 16. So 16a minus 6. Add 6 to both sides. 16a equals 11.2. Divide by 16. 11.2 divided by 16 is 0.7. So a equals 0.7. Okay, so plugging that in, we get our equation equals y equals 0.7 times x minus 3 squared minus 6. I just plugged that a in over here, and everything else should be the same. All right, and you can double check that by graphing that on your calculator if you like. But that's it for today.